Hello students, in this video we will find the position of center of mass of a uniform semicircular ring. Now first we will understand that how we can find the position of center of mass of a uniform body. The formula is x com, that is position of the center of mass of the body, is given by this integration x dm divided by integration dm. Similarly, y com is integration y dm divided by integration of dm, and z com integration z dm by integration of dm. Now what is dm? Dm is, suppose this is the body, dm is an infinitesimal small element of mass of that body. This is dm, and I hope you know that while calculating center of mass we always take a point as the origin of the coordinate system. Suppose this is the coordinate system, the origin of the coordinate system entirely depends on my choice. Suppose I define this point as the origin, so its coordinate is 0 0 0. This is the body, and the coordinate of this dm, suppose, is x comma y comma z. Therefore position of the center of mass of this body, position of center of mass of this body will lie at some point, suppose here, which has a coordinate of x com, y com and z com. This is the basic concept. Now in most of the cases we take the origin at a certain point where the calculation becomes easier, but you can take any point as you wish. Then the calculation would become difficult, but the answer you will get is the same, that is at the same position. Okay, now coming to this video, here we will find center of mass of a uniform semicircular ring. Okay, let mass of that ring is m and radius of the ring is r. Proceed to the next slide. This is the ring, semicircular ring. Mass of the ring is m and radius is r, so this is r. Now we take this point as our origin, so this is x-axis, this is y-axis, and the coordinate of this point is 0 comma 0. Suppose this is O. Now we have to take a small element of mass on that ring. Suppose at angular position theta we take a small element of mass, though it does not look like a small element, but I just take this so that the drawing is clear. And this small element of mass, suppose, subtends an angle d theta at the center O. Now this is radius r, so I can say that the length of this element is r d theta. We know length of arc of a circle, so length of this element is r d theta. This is the element, right? Now we have to calculate the mass of this element. How? It's very easy. The total mass of the semicircular ring is m, and the length of the semicircular ring, that is this thing, the entire this thing is what? Pi r. Therefore I can say that the length pi r has a mass of capital M. Therefore unit mass of unit length is m by pi r. Many people call this quantity as the linear mass density of the ring. Linear mass density means mass per unit length. Now what is the length of this elemental ring? It is r d theta, right? So from unitary method I can say that the mass of this r d theta length is nothing but linear mass density or mass per unit length into length of that element, that is r d theta. So we get m by pi into d theta. The students who like to think more, you can derive this thing just by simply taking this angle. Try it at home. Therefore I can say that the mass of that elemental ring, elemental length, that is small element, is dm equals to m by pi into d theta. This is the first step. Now proceed to the next step. As I showed in the first slide, the formula to find x com is integration x dm by integration dm. Now what is this x? Now, this x is the x coordinate of the elemental mass. Here the elemental mass is situated here. Now what will be the x coordinate of this point? The x coordinate is simply, if I draw a perpendicular like this, and this length is r, so this angle is theta, so I can say this is r sine theta, and this is let first erase it, and this thing is r cos theta. So the coordinate of dm is r cos theta comma r sin theta. I hope you understand. Now I will use this formula to find x com and this formula to find y com. There is no z here because it is planar. Therefore x com is integration x dm divided by integration dm. What is x? X is r cos theta, and see, x is r cos theta, and dm is what? M by pi d theta. So m by pi d theta divided by integration m by pi d theta. Now since m, r, pi all are constant, so I can write like this. Therefore it becomes like this. Okay. Now what about the limit? See, the elemental ring can be from here to here, right or wrong? When the elemental ring is at this point, the angle is 0 degree, and when the elemental ring goes from this point to this point, the angle is this pi. So the limit will be from 0 to pi. Doing the integration, sin pi minus sin 0, sin 0 is 0, sin pi is also 0. So the x com is 0, which indicates that let us draw it again, which indicates that the center of mass of the semicircular ring should lie on this line, because x com is 0, which is obvious from common sense. Now going to y com, proceed to the next slide. Y com is similar, integration y dm by integration dm. What is y? Y is, remember, r sin theta. Dm is m by pi d theta divided by m by pi d theta. Again m by pi cancels, so r integration sin theta d theta by integration d theta. Again the limit will be from 0 to pi, so integration of sin theta is minus cos theta, 0 to pi divided by pi, so it will give us cos 0 minus cos pi. Cos 0 is 1, cos pi is what? Minus 1. So 1 minus of minus 1 divided by pi, which is 2r by pi. Now this is a very important result, 2r by pi. Therefore I can say that if this is the semicircular ring, its center of mass, the x coordinate of the center of mass is 0, that is situated on the y axis, and y coordinate of the center of mass is 2r by pi. So this is the coordinate of the center of mass, 0, 2r divided by pi. This is the length, 2r by pi. Therefore I can say that the center of mass of a semicircular ring lies at a distance 2r by pi from the center on the symmetrical axis. You can say this is the symmetrical axis. Okay, thank you for watching this video. Please subscribe my channel, Phi Solver.